Now that we've looked at all the different ways to factor polynomials, we're going to put it all together and work on a general strategy for factoring polynomials. So as we've mentioned before, the strategy for factoring polynomials starts out with factoring out the greatest common factor. The very first step you should do is always look for a greatest common factor. Step 2 asks you to count the terms of the polynomial. Remember that terms are separated by addition and subtraction. So an example, 3x squared minus 4x plus 2 has 1, 2, 3 terms. So if we count the terms of the polynomial, if the polynomial has 4 terms, we're going to try factoring by grouping. Remember that that's the second strategy that we learned for factoring. We first learned about the greatest common factor, and then we learned about factoring by grouping. Group the terms in pairs and see if the pairs have common factors to factor out. If the polynomial has 3 terms, we're going to factor the trinomial using the AC method or the grouping method. So for 3 terms, we'll use the strategy for factoring trinomials. Remember that tri means 3. Or you can check to see if the trinomial might be a perfect square, as illustrated here. We have 2 special products that actually are trinomials. But these trinomials can also be factored using the AC method. So the fact that these are special products, we just get an option of, if we recognize the pattern, we can find the factors being perfect squares. If the polynomial has 2 terms, then we likely have a special product. And there are 4 different 2-term polynomials, binomials, that we reviewed in the special products chapter. The difference of 2 squares, the difference of 2 cubes, and the sum of 2 cubes. Remember that their factoring formula looks very similar. And then the last one is the sum of 2 squares. The sum of 2 squares is not factorable. So we want to make sure that we remember if there's a plus sign between the 2 squares, we cannot factor it. And then the last step, we check to make sure that the polynomial is completely factored. So we look at each one of the factors that we have and see if maybe we left out or forgot a greatest common factor, or if one of the factors could be factored as a special product. Sometimes that happens. And then we factor. We factor until we cannot factor anything else out. And so there we have our factoring polynomial strategy. Now we're going to put it into practice. Let's try some problems. So remember that the first step is always going to be look for a greatest common factor in all the terms. So in number 1, we have 6, 12, 9, 18. They all have a common factor of 3. 6x cubed is 3 times 2x cubed. 12x squared is 3 times 4x squared. 9x is 3 times 3x. And 18 is 3 times 6. So we do have a greatest common factor present that we can factor out into the front. So let's write down all of the rest of the pieces, the other factors that would make up the original polynomial. So 3 times 2x cubed minus 4x squared plus 3x minus 6. Step 2 says count the terms of the polynomial. Counting the terms, I have 1, 2, 3, 4 terms, which means we're going to try factoring by grouping. So first GCF, factoring by grouping. We'll group the first 2, group the last 2. And here's where we need to be really careful. We need to keep that 3, the greatest common factor of 3, outside the entire time and not forget it. A lot of times students will forget that that 3 is up here in the beginning, and they won't remember to bring it down in the answer. we want to make sure that we bring it down. So I'm going to write it for every single step. Mathematics requires you to pay attention to detail. And for some people that can be a challenge, but we just have to practice. So keep practicing, keep trying. Go back and check yourself. Make sure you grabbed that greatest common factor all the way to the end of the problem. So we'll put the 3 out front. It doesn't matter if I use a rounded parentheses or a square bracket here. There's grouping symbols, they mean the same thing. I'm going to use a square bracket just to make it different from the parentheses. And I look at 2x cubed minus 4x squared and see if they have anything in common. And they do. We have a 2x squared that are in common with the 2x cubed and 4x squared. This plus sign in the middle, I'm going to go ahead and bring it down. And then 3x minus 6, I have a 3 in common. So I can put that 3 as a greatest common factor. In the first grouping, as we stated, 2x squared. In the second grouping, we had 3's. So keeping that 3 in the front. And I'm going to, 2x squared, x minus 2, plus sign, 3x minus 2, close my bracket. I'm not done yet. I've still got this plus sign in the middle I need to resolve. I know I'm done when nothing else can be factored and all of my factors are separated by multiplication. So I've still got this addition sitting here that I need to figure out what to do with. And notice that x minus 2 shows up in both of those terms. So there's another greatest common factor that I can pull out using that factoring by grouping method. So 3 stays in the front. Here comes out x minus 2. And then we write in parentheses 2x squared plus 3, the leftover pieces when we factor out the x minus 2. We're doing that reverse distributive property. This would be our final answer. 3 times x minus 2 times 2x squared plus 3. I can look and see if I can factor anything else. 3 numbers out front we don't need to worry about. X minus 2, there's nothing in common there. We have 2 terms, but I don't have any squares or cubes, and those are the only things present in our special factors. 2x squared plus 3, I've got an x squared, and it's a binomial, 2 terms, but I have a plus sign. With a square and a plus sign, I'm not allowed to factor that. Plus 3 is not a perfect square. So I'm done. I have the factorization for 6x cubed minus 12x squared plus 9x minus 18. Pause the video here for a moment, see if you can try number 2 on your own, and when you resume, we'll talk through it. In number 2, we're going to play the same game. We look for a greatest common factor. The very first step, greatest common factor in all of the terms across. So the first step is find the greatest common factor. And we see we have an x cubed in the first term, but no x in the last term, so we don't have any variable factors. But I notice that I have 15, 10, 60, 40. These 4 numbers are all divisible by 5. I know that 5 divides numbers that end in 5, and 5 divides numbers that end in 0, because 10 divides numbers that end in 0. Let's first take out the greatest common factor. So 5 times 3x cubed, 5 times 2x squared, 5 times, it's okay to pull up your calculator with these numbers. 60 divided by 5 gives me 12, 12x. 8 times 5 is 40, so this is going to be 5 times 8. And then we can pull out that greatest common factor of 5, big parentheses, 3x cubed plus 2x squared minus 12x minus 8. And then we count the number of terms in our new polynomial. 1, 2, 3, 4, 4 terms. So we're going to try that grouping again. Try factoring by grouping. We'll group the first 2, group the last 2. I'm going to bring my 5 down. 3x cubed and 2x squared. They have x squared in common. 3x cubed and 2x squared, well, 3 and 2 don't have anything in common, but x cubed, x squared, we have x's. We actually have x squared in common, so I'm going to factor out the x squared. X squared times 3x, x squared times 2. That minus sign in the middle I'm going to bring down. 12x and 8. No variable in common, but 12 and 8 have 4 in common. So 4 times 3x. 4 times 3x and minus sign 4 times 2. And now we can look at the common factors of the groups. So we'll pull that 5 down. And I see x squared in the first group that they have in common, and 4 in the second group that they have in common. So I'm going to pull out x squared in the first group and write my leftover bits, 3x plus 2. Bring that minus sign down. When I bring the minus sign down here, I factor out the 4 that's the greatest common factor in the second group, but that 4 is a negative 4. So negative 4 times 3x. I can keep the first term positive because I want negative 4 times 3x to give me negative 12x. In the second term, though, I'm factoring out a negative 4, so the 2 here needs to be a positive 2, so that when I multiply negative 4 times positive 2, I'm going to get that negative 8. So we just need to make sure that we've got the right signs going on. Close that one up, and now notice 3x plus 2. We have 3x plus 2's in common, so 5 comes down, 3x plus 2 comes out, because both pairs have that factor in common. And then the next step is to write the leftover pieces, x squared minus 4. And now we do a quick check. 5 is a number, we can leave it. 3x plus 2 has 2 terms, but none of them are squared or cubed, so there's nothing to factor out, and 3 and 2 don't have any common factors. And then we look at this last factor, x squared minus 4. We have a square, x squared. 4 is a perfect square, and it's a difference. This is a special product, so we have to factor some more. We're not quite done yet, and I'm just going to shrink this a little bit so I have some more room in my box. And 5 and 3x plus 2 get to hang on for the ride. X squared minus 4 is a special product. X squared minus 2 squared, a difference of 2 squares, always factors as x minus 2, x plus 2. So we have one factor that's a minus, one factor that's a plus, and then in the first parentheses being squared, x, and in the second parentheses being squared, 2's. And so we can write that over here, x minus 2, x plus 2. Now, don't erase anything. Remember, if you made a mistake, write it on the margin, make a note of it. Allow yourself to see the mistake and see the correction of it so that you can learn from it. And if you want to rewrite this so that it is correct, the margins are pretty generous on these pages, and that is intentional, so that you have room you can rewrite it. One thing I do want to point out, that even though I have this ordering for my factors, if we were to change that order, and I mixed up all the factors, this is still also correct. Remember that multiplication is commutative, meaning I can rearrange the order and I still get the same result. So the ordering of the factors does not matter in our final answer. We will still get the correct solution. So just keep that in mind. Order of the factors ultimately makes no difference. Good job on number 2.